We're going to look at rational functions. This is going to be our fourth example that we have. This one's going to involve something called a removable discontinuity. And a removable discontinuity just means that there is a hole in the graph. And so when you graph it, you're going to have some sort of hole there. All right, let's go through our parts to consider for a rational function. First one being, we're going to find the zeros of the polynomial. And to find the zeros of the polynomial, we're going to set the numerator equal to 0. All right, so we have x is equal to 2. So that's going to be our 0, potentially. 2, we're now going to look for the vertical asymptotes. And that is setting the denominator equal to 0. So we're going to find our vertical asymptotes, and we're going to set q of x, which is our bottom polynomial, equal to 0. So we're going to have x squared minus x minus 2 is equal to 0. We'll factor this into x minus 2. X plus 1 is equal to 0. We're going to x is equal to negative 1 and 2. Here's something that we need to recognize. We have x minus 2 here, but we also have x minus 2 down here. And in fact, our factored polynomial is x minus 2 over x plus 1, x minus 2. Here, we have two factors that are going to be able to cancel each other out. This is where our hole in our graph is going to occur at x is equal to 2. So for all intents and purposes, what we need to do at this point is cross these off and then work with the function just as it is without these two factors. And then just remember at the end, when we're graphing it, we're going to put a hole where x is equal to 2. So going forward, we're only going to think about what happens if we have 1 over x plus 1, and that's how we're going to graph and analyze our function. So now we're going to find where it crosses the horizontal asymptotes. Here. And remember, the horizontal asymptotes, we're looking at the degree at the top and the degree on the bottom. And the degree on the bottom is greater than the degree on top. So because of that, we're going to make as x goes to positive and negative infinity, the actual function is going to go to 0. Fourth part of it, we're going to find the y-intercept. So I'm going to set f of 0 is equal to, and of 0 minus 2 over 0 squared minus 0 minus 2. I'm going to have minus 2 over minus 2, and that's going to be equal to 1. Now, I could have done it with the original function, or I could have done it with the other function as well. I wouldn't have gotten the same value for my y-intercept. Okay. So now, we're going to graph. I'm going to have my vertical asymptotes at negative 1, according to this function here. And I know that I'm going to have something happening at 2, where I'm going to have my removable discontinuity. So now let's look what happens as it goes to negative infinity and positive infinity. Well, at negative infinity, it's going to be a negative number divided by negative infinity squared, which is going to be a positive number. So we're going to end up with a negative number. So since my horizontal asymptote is the x-axis, we're going to be contained in here. And then as we look at what happens over here, and we go to positive infinity, and we have positive infinity squared, that's going to be a positive number. So we're going to have something that looks like this. The only stipulation now is I'm going to have a hole here in my graph. So I should actually kind of white that out or whatever it is, but just understand that we have a hole in my graph right there, and that's going to be my removable discontinuity. So for all intents and purposes, we're graphing it just as if it was this, where we had 1 over x plus 1. But because I have a hole in my graph where I cross these factors out, I need to make sure I put that hole in there.